Assalamu alaikum wa rahmatullah. Inshallah, today we will revise all of previous lessons. We will start with reviewing limits so that inshallah you will be ready for your course. Okay, let's start with the first question. What is the reasonable estimate for limit f of x as x approaches to 4? Here we're asking about x approaches to 4. The first step is to locate the number 4 on x-axis. Here is number 4. And then I'll advise you to draw a vertical line passing through 4 so that you don't be confused. Okay, to get the limit as x approaches to any number, we must find the limit of f of x as x approaches to this number from the right side and as x approaches to this number from the left side. At first, from the right side, I'll go towards 4 from the right side, from the numbers bigger than 4. And then I'll trace the function. Till I found its value. Okay, to the nearest point, to the number 4. The value of the function equal to 6. Wipe out the limit of the function as x approaches to 4 from the left side. We will trace the function from the left side till it hits the line, and we will find that the value of the function is 3. Now both of them are different. They are not the same value, so the limit doesn't exist. If both of them are different, the limit doesn't exist. If both of them equal the same number, so we have a limit. But right now, the limit doesn't exist. So we will choose this one. The limit doesn't exist. Okay, next question. Here we have a table for a function g is defined over the real numbers. This table gives a few values of g. We have a values of g, we have x, g of x, and what is the question? The question is asking you about what is the reasonable estimate for limit g of x as x approaches to -8. The first step is to locate this number on the table or on the graph. We don't have a graph here, we have a table. So we must locate where is -8. Let's start from here. This is -8.1. It's very close to -8. Now this is -8.01. It's closer. So we are getting closer to -8 in this direction. -8.001, getting closer and closer. Now it's -7.9. So -8.001 is bigger than -8. It's very close to it, but it's bigger than it. And -7.99, it's smaller than it. So we have -8 should be located here. This is the place of -8. Okay, and this number is the smallest number to -8 from the left side. Left side, it means the number smaller than -8. Okay, and what is the value of the function is goes to approach to? This one is -0.14. It's very close to 0. And this one is -0.09. It's getting closer to 0. And this one is -0.02. So it's getting much closer to 0. So the value of the function is getting close to the number 0. We will do the same from the right side. We will check the function from the right side. The first number is -7.9. It's close to -8. Now -7.99, getting closer. And this is the closest number to -8 from the right side. What about the value of the function? Here is -0.11. It's very close to 0. Now -0.07. Very close to 0. And now -0.01. It's the same. It's the closest number to 0. So the value is approaching 0 from the right side and from the left side. So what is the reasonable estimate for limit g of x as x approaches to -8? It should be 0. The limit is speaking about the value of the function as it's approaching to a significant number. Okay, so we'll choose 0. Now, next question. We have a graph and we need what is the reasonable estimate for limit h of x as x approaches to -1. The same, we will locate -1. Here is -1. I advised you to draw a vertical line so that it will be no confusion for you. Now to get the limit as x approaches to any number, we must get the limit as x approaches from the right side and from the left side. Let's start from the right side. Okay, from the right side we will trace the function. We stopped here, so it's 3. So from the right side, from x approaches to -1, from the right side, of course, limit of h of x, it will be equal to 3. The same from the left side, the same. We'll trace the function from the left side, it's also equal to 3. So limit h of x as x approaches to -1 from the negative side, so it will be 3. Both of the limits, both sides are equal, so the limit of h of x as x approaches to -1 is equal to 3. Okay, what about this dot? What about this one? As a matter of the fact, this one is the value of the function at x equal -1. So if we told you what is f of -1, it won't be 3, it's the limit, but the value, the actual value of the function will be 4. This function is discontinuous, so it's not with the same. We have a gap here. We have a gap here, or we have a hole here. But when we're speaking about the limit, we are not speaking about this point exactly. We're speaking about the closest point to this one. We're speaking about the behavior of the function as it's a getting approach to -1. So about the limit, it should be 3. I'm sorry, it's -3. I'm sorry, it's -3. This one, -3. This one is -3. Sorry about that. Okay, let's move to the next question. What is the reasonable estimate for the limit of g of x as x approaches to -4? It's the same, locate -4, draw a vertical line. Okay, draw a vertical line, and then get approach to this line from both sides, from the right side and from the left side, because he asked it for -4. So getting close from the right side, trace the value of the function. We found it that it's 2. So as limit of g of x as x approaches to -4 from the right side. From the right side, it means from numbers bigger than -4, which is -1, -2, -3. All of these numbers bigger than -4, and the function is getting towards 2. It's getting close towards 2. Okay, and then we will do the same from the left side. We will trace the function till it stop at -3. So limit g of x as x approaches to -4 from the negative side, it will be -3. They are not equal, so of course the limit doesn't exist. The limit doesn't exist. Okay, limit doesn't exist. Next one. What's the reasonable estimate for limit g of x as x approaches to -1? The same, locate -1, draw vertical line, trace the function from both limits, get both limits from right and left. Trace the function from right, we'll find it to be 3, and then trace the function from left, you'll find it to be the same number, which is 3. So the limit of -1 of g of x as x approaches to -1, it will be 3. What about if I asked you what is f of -1? Sorry, what's f of -1? Just 1 second. Okay, what's f of -1? In the matter of fact, we don't have a point at -1 here, so it's undefined. So there's a big difference between the value of the function and the limit of the function at this point. Here we will choose 3 as the limit of the function as x approaches to -1. We don't have 3, so we'll choose the closest number to 3, which is 3.3. Okay, next. What is the reasonable estimate for the limit of f of x as x approaches to -5? The same, locate -5, draw vertical line. Okay, and then we will trace the function from both sides, from the right side and from Just a second. Okay, and from the left side. From the right side, we will trace the function. We'll find that it's getting close to this number, so it will be 1. So the limit of f of x as x approaches to -5 from the right side, it will be 1. What about the left side? We'll do the same, trace the function, we'll find it to be -4. So limit of f of x as x approaches to -5 from left side, it will be -4. Both of them are different, they are not the same number, so the limit doesn't exist. The limit doesn't exist. Okay, next. Uh, what is the reasonable estimate for limit g of x as x approaches to -5 with the same locate -5? And here he has the drawn line for us. We will get both limits from the left side. So at first, let's trace. Just a second. Yes, let's trace the numbers. Let's trace the function from the left side. It goes down and down and down and down and down without any boundaries, without any limits. So it means limit g of x as x approaches to -5 from the left side. It goes down and down without any limits, without any boundaries. It means negative infinity. This one is negative infinity. Okay, wrap out the right side. It will do the same. We get approach to -5 from the right side. Sorry, from the left side. This one is right side. So from the left side, we will trace the function. It goes up, up, and up. It means limit of g of x as x approaches to -5 from the left side. Left side, it means the numbers are smaller than -5. Okay, right side, it means the number bigger than -5. About this one, it goes to infinity. The same rule. Are they the same or different? This one is negative infinity. This one is infinity. They are different. They are not pointing to the same point. So the limit doesn't exist. Limit doesn't exist here. What about if both of them have infinity? It means both of them pointing towards up. So in this case, the limit will be infinity or unbounded. And if you didn't find any of the two choices, you will choose the third one, which is the limit doesn't exist. But here is your first choice, here is your second choice, and the third choice. If you didn't find any of them, it will be the limit doesn't exist. But here, both of them are different. They are not the same. They are not both of them infinity or negative infinity. One of them is negative infinity, the other one is infinity. They are different, so the limit doesn't exist. Okay, next one. What is the reasonable estimate for limit g of x as x approaches to -4? The same, locate -4 on the number line. Here is -4. Draw a vertical line with your ruler. Okay. So that you don't have any confusion when you get to the right side and left side. For example, to get the limit of g of x as x approaches to 4, I must get it from the right side first and then the left side. To get from the right side, it means as x approaches to -4 from the right side. We'll get the value of the function, it means you will trace the line. But I draw the vertical line so that you will stop tracing the function when you exactly hit the line or just before it. So that you don't have any confusion. I will stop here. And the value of the function is -5. We will do the same from the left side. We will get the value of the function from the left side. So limit g of x as x approaches to -4 from the left side, we will trace the function. Where is the function? It's this blue line. Okay, I will trace it. I found it's the same point, -5. So here, both of them are equal. So we have a limit which is -5. The answer is -5. Okay, we don't have -5 here. It's like looks like this. So it will be -5.2. -5.2. Because it's after -5, maybe one or two decimals. Okay, let's move. What appears to be the value of limit of f of x as x approaches to 3, but this time from the right side? Okay, he needs only one side of the limit, the right side. How to do it? The same steps applies in this one. We'll come to -3, draw your, sorry, it's a 3. Sorry about that. You come to the number 3, you will draw your vertical line, and here we have a vertical line, okay? And then this positive, it means you only trace it from the right side, not from both sides. So when you trace it from the right side, it goes down and down and down and down without any boundaries. It will be negative infinity. If you didn't find negative infinity, it will be unbounded, okay? And if you didn't find negative infinity or unbounded, it will be doesn't exist. Doesn't exist. Okay. Here we have unbounded, we will choose it. Next one, what appears to be the value of limit of f of x as x approaches to -4 from the positive side? The same, we will locate -4, we will draw our vertical line, and this time we will trace it only from the negative side. So we will trace the function goes down and down and down. It goes down without any boundaries, without any infinity, without any limits. So here, I'm sorry, it's from the positive side. Just 1 second. We will trace the function from the positive side, from the right side, not from the left side. Okay, we're going to trace the function from the right side because it's positive, means the number bigger than -4. So we will come from the right side, goes up till you found it to be here. The value will be 1. So the value of this will be 1. Okay, next. What appears to be the value of the limit of f of x as x approaches to 0 from the right side? Okay, this is 0. Draw your line. Trace it only from the right side. Here is the function, goes up till you find it to be 7. So the value will be equal to 7. Next. What appears to be the value of limit of f of x as x approaches to 2 from the negative side? It means from the left side. Okay, we will do the same steps. Get to the number 2, draw your line, and trace it only from the negative side. This one. The value will be 1. Okay, which limit expressions agree with the graph? Okay, we must check each one. You can choose more than one answer here. Okay, you can choose more than one answer. So let's start with the first one. Limit of h of x as x approaches to -4, and he didn't specify any side. He just said -4. So I will draw my line. I'll get the right limit and the left limit. What about the right limit? I'll trace the function. It's 2. At this point, it will be, sorry, -2. So from the right side, it will be -2. From the left side, we'll do the same. From the left side, where is the function? It's down here. We will trace it till we stop at the line. It's -6. They are not equal, so the limit doesn't exist. He said it's equal to -2. No, this is false. So the first one is wrong. Let's check the second one. Limit of h of x as x approaches to the number 0 from the right side, only from the right side. So we'll get as the number 0 located, we'll draw our line, and we'll trace the function from the right side. You could tell me there's a line up there, you can trace it, it's okay, but you must continue tracing the function. I'll trace the function till I stop at the line. Here is the line, and we stopped at the number 2. It's 2, so this one is correct. Okay, third one. What is the limit of h of x as x approaches to 4 from the negative side? Okay, 4 from the negative side. We will get to the number 4. We will draw our line. We will trace the function from the negative side. Here is the closest one, the closest part of the function. So we will trace it till we stop at the line, and the value of the function here is equal to 2. It's 2, so it's correct. This one is correct. So we will choose B and C. Next one. Consider graphs A, B, and C. Which graphs agree with this statement? Choose all answers that apply. So we can choose more than one choice. Okay, this is important. Let's check the first one. At first, he's asking me about the limit as f of x, limit of f of x as x approaches to 2 from the right side, from the positive side. Let's check the first one. Here is 2. I'll draw my line and then trace the function only from the positive side. It's equal to 1. No, I need it to be 3, so this one is wrong. Let's check letter B. I will locate number 2, draw my line, and then I will trace it only from the positive side, from the right side. I found it to be 3. So this one works with us. We'll take this one. It's equal to 3. What about 3? The same. Locate number 2. Get it only from the right side. It will be equal to 3. So this one is also correct. So let's choose B and C. Next one. The function g is defined over the real numbers. This table gives several values of g. Let's head to the question. Is this table appropriate for approximating limit of g of x as x approaches to -7? Okay, let's check it first. We need -7. We'll start with the first value, -7.1. It's very close to -7. It's okay. -7.01, getting closer. -7.001, and then 7. So here should be -7, and this is the closest number to -7 from the left side. And to where the function is hitting to 9.135, 9.124, 9.123. I think it's heading to 9.12 maybe from the left side, of course. Okay. What about the right side? Let's check the right side. 7.1. It's very far away from -7. 7.01. We're getting closer to 7, not -7. So we're heading in the wrong direction. This side is heading to the wrong number. We need to go ahead to the number -7. It's like we need to have here -6.999 or something. Okay, so these numbers are false numbers. We cannot use these numbers. So when I ask you, is this table appropriate or not, you will say no, this table is not appropriate. But why? Because the right side, we missed to get a numbers closer to -7 from the right side. Okay, we'll check the choices right now, and we'll see which one of them is work with us. The table is appropriate? No, of course, the table is not appropriate with us. Letter P, the table isn't appropriate? Yes. But why the table doesn't contain x values from both sides of x equal -7? Okay, let's check this one. Do you have numbers smaller than -7? Yes, we have -7.1. This -7.1, it's smaller than -7. Okay, so we have numbers smaller than -7. Okay, second question. Do you have numbers bigger than -7? We have 7.1. Of course, it's bigger than -7. So about this choice, we do have numbers from both sides. We have numbers bigger than -7 and numbers smaller than -7. So it's not because of this reason. Let's check letter C. The table isn't appropriate. The x values approaching from the right shouldn't be positive. Okay, he's speaking about the numbers. That's formulas are right. Okay, but he said it shouldn't be positive. Yeah, the closest number to -7 is negative, and the values here are positive. So we can use this a choice. This one is the correct one. Next, given the function g and ask it to estimate limit g of x as x approaches to 0. Three students created tables. Each table is accurate. Okay, but which one is the best for approximating the limit? Okay, let's check all of them. The first table. At first, which number we are looking for? We're looking to number 0. So we need numbers that's very close to number 0, getting closer to number 0 from the right side and from the left side. Okay, let's check the first table, -0.25, it's close to 0. Okay, this is a good choice from the beginning. -0.1, uh, getting closer to 0 because it's like -0.10. Okay, -0.05, getting closer. -0.005, getting very close to number 0, and then 0.005. Okay, 0 is here, and these numbers are getting closer to number 0 from the left side, the same from the right side. This is 0.1, 0.05, getting closer, and the same. What about the value of the function? Okay, at first I don't care about the value of the function, because if both of them are hidden to different numbers, the limit doesn't exist, but the table helped us to find the limit. Okay, so I care only about the x values right now to guess the limit. Another thing, actually I don't care about the point 0. The point that I'm asking about, I don't care about it. I'm only care about the numbers that getting closer to this point. It means I'm getting to all the side of the functions, getting closer to number 0 from the left side and from the right side. Because I'm going to choose letter A. Some students saw that we have 0 here as a value for x. They told me, Mister, we already have 0. But I told you before, limit is not speaking about the value of the function. It's a concept that's asking you what is where is the function is head towards to when the x is getting closer to the number 0. So actually, if you have a function like this, and this is your x-axis and this is the number 0, I don't care about the value of the function at number 0. I need to know, is the function is getting towards a point here, is getting towards the same point as the value of the function, or the value of the function is something else. For example, the value of the function at x equals 0 here is, for example, 1. If this is your y-axis, okay, this is 1. But the limit is maybe 5. This is the difference between the limit and the value of the function. And we will use it later, inshallah, in calculus differentiation to know that if the function is continuous or discontinuous. Okay, this is a very important concept for us. So here we'll choose letter A, the first table, and letter B. What's wrong with table B? Here we have -6 is far away from 0. We have values from both sides, from the right side and from the left side, but they are far away from 0. This table is closer to number 0, and this is what I need. Okay, what about the letter C? The table very far away from number 0. This is 14.9, and at the same time, this is values from only one side. We have one side to the number 0, which is the right side, number bigger than 0. We don't have numbers smaller than 0. So it doesn't work with us. Okay, let's move to the next one. The function h is defined over the real numbers. This table gives several values of h. Okay, we have a table that have some selected values for the function h. He's asking us, is the table appropriate for approximated limit h of x as x approaches to 1? If not, why? Let's check it. At first, we will focus at the value where x equals 1 or getting closer to it. So let's start. This is 0. Okay, smaller than 1. So this is the left side. Let's check the next one, 0.5. Getting closer to 1, 0.75. Getting closer and closer, 0.85. Okay, 0.95. Okay, getting closer and closer, 0.995. Okay, this is the closest value to the number one, but we have only one side. We don't have the other side. We have the left side numbers are smaller than one, but we don't have the right side, which is number bigger than one. So is this table appropriate? No, it's not appropriate because we must have the limits from both sides. This is the reason we have only the limit from one side. Let's check the choices. I'm sorry, is this, I think it, okay. The table is appropriate? No, the table isn't appropriate. The x values only approach one from one direction. Yes, this one. The table isn't appropriate. The increments in x values are constant. I don't care about the increments. I'm caring about we are getting closer to one from both sides. Okay, next question. The function h is defined over the real numbers. This table gives several values of h. Okay, we have a table. The same question was asking about limit h of x as x approaches to 1. Let's check where's 1. 0, 0. It's the same question, sorry. It's the same one. Next question gives the function f and asks to estimate limit of f of x as x approaches to 5. Three students create a table. Which one of them is the best estimation? Okay, we searching for number 5. Let's check the first one. Negative 5.5, it's smaller than 5. Okay, this is the left side. Negative 5.05, we're getting closer to negative 5, not to 5. We need positive 5, not negative 5. Negative 5.005, and then we have 5. At first, I told you we don't care about the value where it's going to we're heading to. We're caring about the values beside it from both sides. So negative 5, it's a little bit far away from 5. We need it from the right side to be something like 4.99, and from here something like 5.001, something like this. Okay, let's check letter B. 4.95, okay, it's smaller than 5. 4.995, again closer to 5, and then 5.05005. So 5 is here, and this is the closest number to 5, which is 4.995. This one is very good from the left side. What about the other side? We're getting closer and closer and closer, and this number is very close uh, to 5 from the right side. And of course, we have the numbers. We don't have a very far away distance from each other. We have 5.5, then 5.05. It's okay. The increments here is okay. So we will choose letter B. This table is the best approximation to get the limit as x approaches to 5. What about the last one? We head into 5 from only one direction, from the right direction. Okay, we don't have any values smaller than 5. Okay, next. The function f is defined over the real numbers. This table gives selected values of f. We need limit of f of x as x approaches to 8 only from the negative side. At first, what's the meaning from the negative side? From numbers smaller than 8. Let's check x values and let's search for numbers smaller than 8. 7.6 is smaller than 8 and it's very close to it. 7.98 is getting closer. 7.999, it's getting closer and closer. Don't say, Mister, hey, we have 8 here. We don't care about 8. We care about the values hitting to 8, okay? So let's check the value of the function because I'm asking you about the limit. The value of the functions as x approaches to 8 from the left side. Okay, so the first value is 99. We need to determine where the function is going towards to. Okay, this is 99 and this is 425. There's a big difference between them, and this is 750. The numbers are getting very bigger and bigger and bigger in much bigger jumps here. So here is the function is heading to infinity. It's heading to infinity, okay, or unbounded. If you didn't find infinity, you will choose unbounded. And if you didn't find any of them, you'll choose doesn't exist. But here the first choice for us is infinity because the values are getting bigger and bigger very fast. It will be unbounded. Okay, next one. It's the same table. Next. Okay, the function f is defined over the real numbers except at x equal negative 3. Okay, we don't have the value of the function here, it's undefined, but we can get the limit. And this is the usage, the benefit of the limit. Okay, we can get for some points that it already doesn't exist. So I'm looking for negative 3 or getting the numbers headed to negative 3. Let's start with the numbers smaller than negative 3. Negative 3.4, negative 3.02, we are headed to negative 3. Negative 3.001, and this is negative 3. I told you before, we don't care about it. We care about these numbers. We're getting closer to it. What do we need here? We need, yes, we need to get the limit of f of x as x approaches to negative 3, but from the right side. This is from the left side. So let's check the right side, negative 2.6. It's bigger than negative 3, getting closer to negative 3 and closer, and this is the closest number. Okay. What about the function? The value of the function as we gain closer to negative 3. This is 1.5, 1.03, 1.001. I think we're getting closer to 1. So the value of the limit here from the right side will gain closer to 1. Okay? And we only check the right side because he's asking about the right side. We have it 1. Next question, the function h is defined over the real numbers except at x equal negative 7. Okay, and we need the limit of h of x as x approaches to a negative 7 from the right side. The same, this is negative 7, I don't care about it. This is the right side, we get closer and closer to negative 7. What about the value as we gain closer to negative 7? Negative 497, negative 664. And then negative 830. The numbers are getting small very fast this time. So the functions gain like this, it's making like this if you draw it. So it's heading to negative infinity. If you didn't find negative infinity, it will be unbounded. And if you didn't find unbounded, it will be doesn't exist. So we'll choose here unbounded. Next question, we have this table and was asking about 4 from the left side. So this is 4, we need it from the left side. Of course, I don't care about the value of the function. But where's the left side? Left side, it means number smaller than 4. 3.9 is smaller than 4. And we're getting closer to 4, and this is the closest number. Okay, what about the value of the function? Negative 4.0, negative 4.0, negative 4.00, it's heading to negative 4. So the answer is negative 4. Not because the value of the function at 4 is negative 4. No, not because of that. It's because we get heading to negative 4. Okay? So it will be negative 4. Next, we have two functions, function h and function f. And I'm asking you about the limit of f of x plus h of x as x approaches to negative 3. Okay, as I told you before, to get the limit of anything as x approaches to any specific number, you must get it from the right side and from the left side. So I will start with the right side and then the left side. And this is for f of x plus h of x, the same f of x plus h of x. Okay, if both of them are equal, so we have a limit. If both of them are different, we don't have a limit. Let's start from the right side first. Where is negative 3? Here is negative 3. Draw a line. The same, both functions, okay? Draw a line. And then let's trace it from the right side only in f, in function f. I'll trace it from the right side only. Okay, it means I'm going in this direction. Here is the function. The value of the function is 0. This one is 0. Okay, and then we'll do the same at h. I will trace it from the right side only. And here the value of the function is 2. So you can say it's 0 plus 2, which is equal to 2. What about from the left side? We would do the same. I would trace the value of the function here. It will be 3. And I will do the same with h. It will be 2. So it's 3 plus 2, which is equal to 5. They are different. They are not the same value. So here the limit doesn't exist. Okay? Because they are different. The limit doesn't exist. Next question. Function h and g are graphed. Okay. I need the limit as x approaches to -3 for the sum of both of them. We will do the same. We will come to -3 at h, draw our line, trace it from the negative side, it's 3. So at first I need it from the negative side. To limit of h plus g, okay? Here it will be 3 for h. Let's check g. Here is -3, draw your line. It will be 2. So 3 plus 2 is equal to 5. Is equal to 5. We will do the same from the right side. X approaches to -3 from the right side for h plus g. Okay. I will do it in h. We trace it on the right side. It's 3. We'll do the same at g. It's 2. So it's 3 plus 2. It's also equal to 5. Both of the answers are equal, so the answer must be 5. Next. Okay. Here, what do we have? We need the limit of, uh, of 5 f of x as x approaches to 3. What we will do is this part. This is a property of the limit. You can write this constant out. It's the same as 5 of limit f of x, for example, as x approaches to 3, if you want to call it like this. So if you have a limit here, you will multiply it by 5. If you don't have a limit, it doesn't exist. So I will check the limit of f of x as x approaches to 3, and then multiply it by 5. And then we multiply it by 5. Okay, here is 3, draw your line. Here is our line. And then we will trace the function from both sides, from the right side and from the left side. Both sides are getting to 2. So the answer will be 5 times the limit, which is 2. So 5 times 2 is equal to 10. The answer is 10. Okay, next. Okay, this one. We need the division of f of x over h of x as x approaches to -1. We'll do the same. I'll start with f of x. This is -1. The same at h. Draw a line. Let's start with limit f of x over h of x as x approaches to -1, but from the left side, and we get it one more time from the right side. Okay, let's start from the negative side in both functions. I will start with f here. Again, from the left side, we find it to be 0. So this is 0 over. What about h? Let's come from the left side. It goes up and then down. It's -1. 0 over -1 is equal to 0. Let's check the right side. Okay, let's check f first. The right side, we will come from here. It's also 0 over. Let's check h. We come from here. It's 2. So 0 over 2 equals 0. Okay, here we have 0, here we have 0, so the limit is equal to 0. Next one, function h and g are graphed. Okay, What about this one? If you have h of x, f of x, it means multiplication. It means multiplication. And we will do the same. We'll find the limit from right side and from left side. Okay, I'll do it quickly. This is h. I will get the limit from the left side. It goes up, it goes down. It's 2. So as abbreviation, this is from the left side and this is from the right side. Okay, just as abbreviation so that we can do it quickly. From the left side, h of x is equal to 2 times. What about here? This is -1. Draw your line and trace the function. Don't be confused about this, the point down, okay? From the left side, it's 4. So it's 2 times 4, which is equal to 8. Now we will trace it from the right side. I'll trace h. I go up and then down. It's 2 times. Do the same. Trace it up and down. It's the same as 4. 2 times 4 is equal to 8. So from both sides is equal to 8. So the limit is equal to 8. Next one. Functions h and g are graphed. Okay. I need the multiplication, the limit of g of x times h of x as x approaches to -2. The same, we'll get it from the right side and from the left side. This is from the left side and then from the right side. Okay, if they're equal, there's a limit. Not equal doesn't exist. This is -2. Draw a line, get it from the negative side here. It's 4. So g here is 4 times. Let's check h. I'm sorry for the line. Don't have any rulers here. Okay, get from the left, it will be 2. So it's 4 times 2, which is equal to 8. Let's do the same from the right side. Here from the right side, again closer to -2. It's 2 times the same, getting closer to 2. It's 2. 2 times 2 is 4. They are not the same. They are not the same. One of them is 8, the other one is 4, so the limit doesn't exist. Let's move to the next one. Functions g and f are graphed. Okay. Yes, this one is called composition of the function, and it's the same if you saw it like this: f circle g of x. Okay. This one you will start with the ones that have the bracket of x, like this one. It's g of x, so I will start with g. The same g of x, I will start with g. It's this bracket. I will see which function is closest to it. So we have function that I will do it first, number 1, and then function number 2. At first, you will get a result from the first function and then use this result in the second function. I will show you. I will show you how to do it. Okay. Let's start. At first, in any question asking you about the limit, you must get it from both sides. If it's asking you about limit of f of g of x as x approaches to 2, you must get from the left side and from the right side. Okay. This one is very important. So I write the full question f of g of x, and here limit of g of x. Okay, let's do it step by step. At first, let's solve this one. I will equate the number 2. Here is number 2, but in which function first? We told you you must start with g. This is g. I will start with it. I will draw my line. What I will do here, I will trace the numbers as x approaches to 2 from the left side. Okay, the result is 3. What's the next step? It's like here we have 3. So I need the limit not as x approaches to 2 from the left side. No, I will switch this 2 with the number 3. So it will be, I need the limit as x approaches to 3 from the, sorry, I got it from the right side. Anyway, this one from the right side and this one from the left side. Okay. So I need to get it as x approaches to 3 from the right side, not 2, because I got the first function from function g, I got the result 3. So in the second function, which is f, I will use this 3. So the function is getting towards 2, so the answer here is 2. Let's check it in the next one, okay? In the next one. Here from the left side. Okay. I will start with G. I go towards 2 from the left side. Okay. Trace the function. We got the same result, which is 3. The answer is not 3. We're not done yet. We will switch this 2 by the number 3. It means I'll go up at function f. Okay. I erase this one so that you can see it clearly. I go up as function f. I will locate the number 3, not 2. We don't have 2 anymore. I will locate the number 3, draw my line so that I'm not confused about anything. Trace the function from the left side, goes down and up till you find it to be at exactly the number 2. So we have the same answer, which is 2, so the answer is 2. We have a next example, inshallah, that will be very clear for you. Okay. The same, we have a composition of the function. At first, determine which function you will solve it first. It's f. I must solve f first. I will get it from the left side and then I get from the right side. Okay, let's start to get it from the left side. I start with f first. This is f. Where's 3? This is 3. Draw a line. Approaches to this number from the left side, goes up, goes down till you hit the line. We found it to be -1. Why would do this -1? Take it and trace it as a function g. So at function g, I will trace the number -1. From which side? The same side that you trace the number 3 at the function f. I will trace it from the left side. Okay, so let's trace it from the negative side. It will be 3. I will do it again. Okay, just a sec. Okay, right now I will trace the function f as x approaches to 3 from the right side. This is the function f. I'm getting close to the number 3 from the right side. It goes up and up and up. We found it to be -1. Okay, what I will do is this -1. I will go to the second function, come to the number -1, and trace it from the same side, which is the right side. So I would trace it. I found it to be 0. So the answer here is 0. So they are not equal. So the limit doesn't exist. And of course, please, when you have the question here, you will write it as a full question. Okay, we will do it like this right now so that we can make it just a little bit quickly. Okay, let's move to the next question. Functions f and h are graphed. Okay, this is f, this is h. I need the composition of the function as x approaches to 0. I will start with h. Where is h? This one. Start with the number 0 and get it from the left side and then from the right side. Okay, let's do it. This is 0. Make your line. Get it from the left side. Trace the function. It's 1. What I will do is this one. Go to the next function. Trace the number 1 from the left side, the same side. Okay, it's equal to 2 point something. 2 point something. Let's make it 2.3, for example. Do the same. Do the same again. Go to the h function. Locate the number 0. Draw your line and then trace it from the right side. It goes up and up and up. It's 5. Okay, what I would do is this 5. I will trace it here. In this graph, it's not completed. I will just make it like this. Okay, I'll trace the number 5. Where's the number 5? This is 4, this is 5. For example, this is 5. I will draw my line and then I will trace it from the right side, the same side. Okay, from the right side. It goes something like this, 5 point something. Okay, 5.3 for example. They are different, so the limit doesn't exist. This question is not full here. Okay, but you can complete it like this. Of course, it's not uh, something like this is not coming as a quiz, but you have it. You have it in your worksheet, so you just need to complete it like this so that you can solve it. Next one. Okay, this question. What is missing with this one? We don't have the graph. So we are going to do it with some steps. What is this step? The first thing, I'm asking you about the limit of g of x as x approaches to negative 3. And it's algebraically, this one. I got g of x as root of 7x plus 22. What is the first thing that I will do? I will just substitute. I will just plug in negative 3 in place of x. So all what you need to do is write in like this. Square root, this is 7 bracket in place of x so that you can replace it with anything. And this thing is the same point is asking you about, which is negative 3. Okay, calculate it with your calculator, you'll find it to be 1. Okay, what other choices that could we have? The first choice is we have an answer. We have an answer as it's done. This is the limit. Okay. The second choice is making this one with your calculator and you find it to be math error. Math error means two things. And math error, most of the time you will have it like a fraction, okay? Something like this. You could have something over 0, for example, anything, maybe 6 over 0, 6 over 0, okay? Something over 0, it means this limit doesn't exist, doesn't exist. And in this case, you're done. It's okay. You finished. So it could have something like this 3 minus 3 over 7 plus 4, for example. This is 11 over 0. So it doesn't exist. And if you write it all of them in your calculator, you'll find it to be math error. So you should write the top part only and then the lower part, which is the denominator. You could write the top part only. Okay. If you want it to be a number, it means it's something over 0, so the limit doesn't exist. What about if you found it to be 0? It's 0 over 0. This quantity is called undetermined quantity. It means you have an answer, but right now you don't know what is this answer is. How to get it? In matter of fact, you will use one of three methods, and you should recognize your question and which method you will use. The first one is factorization. Okay, second one is conjugate. Third one is trig trigonometric identities. Okay, this is trig identities. Factorization, all of us know it, and we can use our calculator. Okay, so this one is very easy. This one is just some steps that you will do it, and most of the time you will have root plus or minus something. Okay, you will multiply by the conjugate up and down. It's specific steps, and you will do it. This one, trigonometric identities, it's a couple of rules that you will keep and you will use it so that you can solve a question. Sometimes there's a tricky questions that contains trig functions and with roots. In this case, the priority for conjugate, you will start with conjugate first. But in main, we have three methods to solve 0 over 0. You will use one of them so that you know the answer. Of course, the first step is substitution, plug in the number so that if you have an answer, it's okay, you're done. If you don't have an answer, you must use one of them. Let's move to the next one. The same, plug in the numbers. You can make it ready, make brackets in place of x, -5, and then power 2 plus 1. Okay, we're plugging 2, so it will be like this. A calculator with your calculator, it will be 8 minus 20, it's -12, -11. Okay, the answer will be -11. For -20, -20, -19, -19, -11. Okay, next one, the same, plug in the numbers first. So it will be 3 minus 5 power 2, 2 times 5 plus 1. Do it with your calculator, it will be here. This is negative 22, and this one is 11, so the answer is negative 2. Next, the same, plug in the numbers. This is 6 brackets plus 13. Okay, I'll plug in 2, so it will be 5. Next, okay, this one, we'll just plug in 3, so it will be 3 minus 5 power 2, 3 minus 3 power 2. When you write it with your calculator, you'll find it to be math error. So what I will do in this case, I will only calculate the top part. You will find it to be 4. Okay, this is something, and of course the town part will be 0. Okay, the denominator will be 0. But if you calculate it so that you can be sure, this is 3 minus 3, 0 power 2 is equal to 0. Something over 0, it means it doesn't exist. And you're done. This one is done. Doesn't exist. Okay, the same, plug in the numbers. This is 3, and then bracket minus 2, bracket plus 2, and then we'll plug in 4. We'll plug in 4 in place of x, substitute it with 4. 3 times 4 is equal to 12. This is 4 minus 2 is 2 times 4 plus 2 is 6. So it will be 12 over 12, which is equal to 1. It will be 1. Next, the same, plug in 2, so it will be 2 plus 2, 2 minus 2. You'll find it to be math error. Calculate the top part, you'll find it to be 4. Down part will be 0. So 4 over 0, something over 0 doesn't exist. Next, the same, we'll make it like this, negative 5 plus 1, all power 2, 8 minus negative 5. Okay, if you calculate it with your calculator, at first I'll do it with my mind here. This is 16, and this one is 13. So it will be 16 over 13. Next, okay, about this one, sec of x. At first, we have sine, we have cosine, we have tan, and we have the reciprocals of these functions, which are the reciprocal. Okay, it's sec, cosec, cotan. Sec is the reciprocal of cosine. It means 1 over cosine. Cosec is the reciprocal of sine. It means 1 over sine. And cotan is the reciprocal of tan. Okay, to get this one, I must get 1 over cosine because in our calculator we don't have sec or cosec or cotan. So we'll use sine or cosine or tan. This one I will calculate like this, 1 over cosine. Okay. At first, I plug in the number, but you must be careful about something. On your calculator, you find a letter D like this. It means your calculator is set it up on degrees. On degrees. So you cannot use pi. If you write it here pi over 3, this is wrong. You must replace pi with 180. So it will be 180 over 3. Just replace pi with 180 and then calculate your answer. Here be 60, cosine 60. At the end it will be 2. Okay, but what about if you want to use pi? I want to use pi. This is 1 cosine. It's my number pi over 3. What I will do here? Okay, in this case you must change your calculator from degrees to make it radians. Okay, and it will be this letter D, it will be changed to R. How you do it? You will press mode, okay, mode, and then red. I think you will find it number 4, red. Okay, it will change it from degrees to radians. Right now, you will write 1 over cosine pi over 3. Your calculator will recognize it. Okay, in radians, and you will find it the same answer to be 2. Okay, I suggest that you can replace it with 180 and use the same system as your calculator, which is degree. This is my advice for you. Okay, next one. So it will be 2. Next one. Okay, this is sign the same. I'll switch. I replace the function. I replace pi with 180, and it will be equal to. Of course, this is in degrees. My calculator set it up in degrees. Next one. Okay, this is cotan. Cotan, it means 1 over tan. Okay, put 0 here. Or you can replace it like this. So you can do it with your calculator like this, or you can make it like this. This is cosine, okay, over sine. One of them. But I suggest this one. Okay. And the same, I put 0 here. It will be something over 0. It will be 1 over 0. And the same here. You will find it to be math error. And we know that the top part is 1. So if you calculate it 10, 0, you find it to be 0. It means something over 0. It means unbounded. Unbounded or infinity. But here, unbounded, infinity, the limit doesn't exist. You can choose the limit doesn't exist. Okay. This is 1, this is 0. Yes, so the limit doesn't exist. Next one. Okay, tan x the same. We will plug in 0, so it will be then tan 0, which is equal to 0. Next one. Okay, this is a piecewise function. Okay, how we will do it? Here in the limit, he's asking me about -1 from the left side. What's the mean from the left side? From the numbers smaller than -1. You must check here. This is the domain. It means that we have a function g of x and it's split it to more than one part, maybe two parts, maybe three, maybe four. It's okay. But right now I'm searching for -1 and it's from the negative side, so it's a number smaller than -1. Let's check the first one. This is x. My numbers are smaller than -1. It's this one. What about here? The second one. X. My numbers bigger than -1. No, I don't need this part. I need the top part only. Where's the numbers that are smaller than -1 so that I can get from the left side. So what I will do, I don't have any graph. All what you need to do is plug in -1 here in the function. So it will be e power -1. Okay, if you cannot find it because you don't have a power -1 in the choices, you will calculate this one with your calculator. You will find it to be something with decimals, okay, and then you will calculate all of the answers. The ones that have the same answer, you will choose it, okay. But if you know the rule, this is e power -1. It means 1 over e. It's the reciprocal of e, okay, so it will be 1 over e. Next. A piecewise function is asking about -3. At first search, where is -3? Okay, here is tell me all of the numbers are smaller than -2. Yes, -3 is smaller than -2. Here is -3. Okay, where about numbers bigger than -2? No, -3 is not bigger than -2. So I will use the top part. Okay, this is 2x plus 1. I will plug -3 here. I will substitute with -3 here. So it will be 2 times -3 plus 1. It will be -5. So the answer will be -5. Next. Okay, I'm asking you about 2. I didn't asking you about a specific side, but I'm asking you about the limit as x approaches to 2. So I must get it from both sides. At first I would search where is 2. I have 2 here and I have 2 here. In the matter of the fact, you know that I'm searching about 2 specifically. I'm searching about the numbers getting close to 2 from both sides. That means the number is smaller than 2 and numbers bigger than 2. To get the limit of g of x as x approaches to 2 from the left side and limit of g of x as x approaches to 2 from the right side. Okay? Okay. Where is the left side? Where is the numbers smaller than 2? Here is x, here is the number smaller than 2. So I will check this function. I will substitute with 2 in this function. It will be len of 2. This is the answer. Keep it. Let's check the second part, which the numbers are bigger than 2. This is the numbers from the right side. All what you need to do is plug into this function. So it will be 2 power 2 len 2. It means 4 len 2. Here's the question. Are they equal? No, they are not equal. They are different. So the limit doesn't exist. Next part, I need the limit as x approaches to 4, so I must get from both sides, from numbers bigger than 4 and from numbers smaller than 4. Here is x, numbers smaller than 4. Here is x, numbers bigger than 4. I must plug in 4 in both bars and calculate what is the result of each one of them. If they are equal, so we have a limit. If they are not equal, we don't have a limit. So it's 2 power 4, the first one. This is from the left side, by the way. This is from the left side because numbers are smaller than 4. 2 power 4 is equal to 16. And then I plug it down. It's 8 root 4, which is 2 times 8, which is 16. We have both of them are equal, so the limit is equal to 16. Okay. Next question is the same. Okay. And now we have this one. At first, we'll plug in 5, so it will be like this 12 times 5 minus 60, and then 5 power 2 minus 6 times 5 plus 5. When you write it by your calculator, you'll find it to be 0 over 0. Here, I will calculate the first part, it will be 60 minus 60, which is 0, and then the down part, the denominator, it will be 25 minus 30 negative 5 plus 5, it will be 0. 0 over 0. It means you will use one of three ways to solve your question. Factorization, conjugate, trig identities. In this case, and all of the time, by the way, you must recognize your question. You must know which method you will use. In these types of questions, when you have functions like this, up and down, we will use factorization. Okay. The first thing in factorization is taken now is the common factors. This is 12, and here we have 12. Here we have 12 5 times. It's 12 times 5. So we already have 12. And this one is only 1 times 12 times 1. So in the first part, we can take 12 out as a common factor. Okay, cross 12, it will be 1x, which is x. And here cross 12, it will be negative 5. The same down, and you can do it by your calculator. This is x power 2. Why is multiplying what's the two quantities? If you multiply by each other, you will get x power 2. It's x times x. Okay. And then what is the two numbers that if you multiply them, you'll get 5. And if you add them, you will get negative 6. It will be negative 5 and negative 1. Okay. Here's the part that makes our function giving us undetermined quantity. It's x minus 5. I will curse it up and down, and I'm come up with 12 over x minus 1. What I would do next, I would do the first step again. I will substitute with 5. It will be 12 over 5 minus 1, which is 12 over 4, which is equal to 3. So the limit is equal to 3. Next, okay, the same. I will start with plugging in 3. So it will be 3 power 3 minus 9 times 3 over 3 power 2 minus 3 times 3. You will find it to be math error. Calculate the first part, you'll find it to be 0. Calculate the denominator, you'll find it to be 0. Undetermined quantity. So I will use one of three ways: factorization or conjugate or trig identities. I will use a factorization. First step, taking out common factors. I have x common between them. Okay, wipe out the power. I will use a smaller one, which is x. Remove x from x power 3. You will find it to be x power 2 minus 9. And then down the same, we have x common factor. Remove it, you will come up with x minus 3. Here we have x up and down, cancel it. It's one of the reasons that we have undetermined function, undetermined quantity. And then if you plugged in 3 again, you will find it the same math error, undetermined quantity. It means you must complete all of the full factorization. This part is okay with us. It's x minus 3. We don't have any problem with this part. But the top part, we need to factorize it one more time. It's the difference between two squares, so it will be x minus 3, x plus 3. Okay, cancel x minus 3 with x minus 3. You will come up as x plus 3. What you will do next, the same, plug in 3 in your question, so it will be 3 plus 3, which is equal to 6. Okay, we will factorize, because if you plug in -1, you will find it to be 0 over 0, just as abbreviation for all of this. Okay, I took out 12x power 2 as a common factor. It will be x plus 1, because we don't have anything here, which is 1 times a quantity, so it will be 1. And down we'll take out x power 2, and the remaining part will be x power 2 minus 1. And then we'll cross out x power 2 up and down, and if you plugged in the function is -1 again, you will find it to be still undetermined. It means we still have to factorize it more further. The down part, I will make it as the difference between two squares, so it will be x minus 1, x plus 1, and then I'll cross out x plus 1 from up and down, and the remaining part will be 12 over x minus 1. Then plug in -1 again, so it will be 12 over -1, which is -2, so it will be 12 over -2, and the result will be -6. Okay, the same, we have factorization. So what we will do, of course, the first step is plug in -3. You'll find it to be 0 over 0. You'll use factorization. You will take x from here as a common factor. You will have x power 2 plus x minus 6. And down we'll take x as a common factor. You will have x plus 3. The same, x will go out with x. And if you plug in -3 again, you'll find it to be undefined, undetermined, so you must factorize it more further. This is x, this is x. Two numbers, if you multiply them, you'll get -6, and if you add them, you'll get it +1. It's -3 and +2. And here down we have, I'm sorry, it's +3, -2. Okay, +3, -2. And here we have x plus 3. We will cross out x minus x plus 3 with x plus 3, and the remaining part will be x minus 2. We will plug in -3 again. It will be -3, -2, it's -5. Okay, and we'll stop our revision set here. Good luck inshallah with your quiz, and if you have any question, you are free to ask me anytime. Thank you. Assalamu alaikum wa rahmatullah.